The topic on investigation of relationship between variation of color, change of fruits with their shelf life and other physical properties. Ms. Udeshi is a temporary instructor of Faculty of Science, University of Colombo. Her research interests include optics, electronics and instrumentation. Ms. Udeshi.
Good evening, everybody. I am KMW Udeshi. My research is investigation and relationship in between the surface color of fruits, with its shelf life and with its physical parameters. This was supervised by, as the chairperson said, former Dean of Faculty of Science, University of Colombo, Mr. Professor T.R. Aryaratna, and physics lecturer at University of Colombo, Mr. H.H. Jaivera. As we all know now, people are more prefer to eat healthily, so they are there's a trend that they are buying so much fruits and vegetables when they go to the market. So in near future there will be there's a trend that there will be large fruit or vegetable markets. For consumers it will be easy if there is an electronic device to measure fruit maturity and to sort fruit automatically, like whether the fruits are in a good condition to transport or whether it's suitable to put in the market shelf. So in my research I investigate some relationships in between the fruit physical parameters with its shelf life. Also this kind of data analysis will improve the competitiveness and the profitability of the fruit and vegetable market. According to my literature review, there were very few papers on the pineapple maturity, and also as the main parameters of fruit maturity they used firmness, surface color, fruit size, fruit shape, treatable acidity, etc. So I chose surface color and soluble solid content because for the pineapple, rather than the other fruits, when we are going to buy pineapple, we observe the color and also we smell its tasty smell. So it's soluble solid content. And also I try to do a investigation on firmness, and I used the firmness tester Wagner ET. It was a destructive method, but my data analysis shows very slight variation of firmness with the pineapple, so I was advised to omit that parameter. Also the data collection I've done in the morning, day by day in the morning at 8 a.m. to 10 a.m. From picked up day to starting of the rotting date. This is the refractometer I've used to measure soluble solid content. The unit it used was a brick scale. Brick scale is a percentage. It shows the concentration, total concentration of the soluble solid content. The graph the relationship I found was like this. Each line shows a variation of soluble solid content with its shelf life. Each line is shows one pineapple. So as you can see, it began with in between 7 and 9 brick scale and increases to in between bricks value 11 and 13. And also you can clearly observe that almost all the pineapple shows a linear variation with linear variation with its shelf life. So I calculated gradients and intercepts. Average gradient was 0.33 and average intercept was 8.36. For the color variation, I used diffuse reflectance, and there was few disturbances occurred because pineapple has rough edges, and also as all fruits, it has a oval shape. So when light beam hit the surface, it almost many of the light was scattered. And also diffraction occurred. To reduce these errors, I used a special technique, spectral polarized diffuse imaging technique. This is the setup I've used. In the dark box, I've prepared to put pineapple manually, and to give a even lighting, I've used a white LED panel. And the light came through the filters, polarizers, and also the receiving light by the CCD camera also filtered by the polarizer and stored all the images in the computer, and used MATLAB 2010 software to analyze data because it has advanced image processing techniques. Also to reduce color intensity variation, I've used black reference and bright reference. That means I've used as the background I've used white and black panels. This is the relationship I've got: RGB pixel averages versus age. Age means shelf life. As you can see, in the blue channel, I got an unexpected, unusual variation because at the 4th day, blue get decreases, and again it get and when the fruit matured, it again get increases. This happens because pineapple is because of some kind of a special attribute of pineapple. Because raw unmatured pineapple has a white dust on it. And that is why blue at the beginning blue has a higher value, and when fruit get matured, that white dust disappear and yellow appears. Again blue channel decreases, and when the pineapple get matured, it dries. Then again in the edges dryness appears, white or grey color. So blue channel again try to again increases. So using image processing, I remove all the white portions of the images. Then this is more accurate graph, more accurate relationship. So you can see almost blue channel is steady, and at the beginning you can see green has a higher diffuse reflectance, and eventually it is lower than red, and in between 8th or 6th day it get both green and red channels get saturated. Yes, those are the relationships I got for the surface color versus shelf life. Because blue is steady, to reduce the geometric error. Geometric error means the oval shape of the fruit. To reduce that error, I've got red versus red by G ratio, and got this relationship against the shelf life. Here again we can see at the beginning the color. So the color values shows lower lower than 1 because at the beginning green is higher, green channel is high, red is lower than green, and eventually it get saturated in between 8 and 10 days. Finally, as the final resulted model, I've investigated relationship in between surface color and the soluble solid content. As you can see, when soluble solid content get 11 Brix value, color variation stops. Color remains as it is. And also at the beginning shows the lower value than 1. I can conclude that here in my research I can conclude that diffusely reflected images also also shows that when fruit get matured, it matures the color changes from dark green to yellowish orange, and also for fruit maturity data analysis using red to green ratio is more sensitive, and there is no variation of the blue channel and that fact we can use to reduce geometric errors. And for pineapple, after 10 days there is no diffuse color changes. Soluble solid content for fruits, when we are going to make, I can conclude that soluble solid content has the Brix value 13. It's the maximum Brix value for fruits. And also for pineapple, after 10 days that 13 Brix value appears and it remains as it is. The remarkable fact and important fact I found in this research was soluble solid content varies with its shelf life linearly, and it independent from its fruit size and the fruit shape. The resulted model between surface color. This is the model I'm continuing my research on this fact. The resultant model in between surface color and soluble solid content with shelf life is its correlation was 0.2. That means it's a polynomial model. This correlation can use for the electronic device, because for the pineapple the main and most probably only parameters which can affect for the shelf life will be surface color and soluble solid content. So correlation of 0.26 will be a remarkable fact for to develop an electronic device. And I can recommend for pineapples, for pineapple, if consumers want a day to put their pineapple on the shelf, then after plucking pineapple, within 7 days they can put pineapple on the shelves, and also can keep them over a week without rotting it, because pineapple fruit get ripened within 12 days upon plucking. So thank you.